Imagine we're in a city built on a grid system and we need to find our hotel. In the diagram shown, with north pointing upwards like on a map, we can get there by going 4 blocks east and then 3 blocks north. The position vector of the hotel from our starting point then has a magnitude of 5 blocks at a direction of 53 degrees east of north. But unless we want to bulldoze through people's houses and businesses, then we'll probably take the 4 east plus 3 north route. 4 blocks east plus 3 blocks north specifies the position of the hotel on the two-dimensional surface called the ground. It's a two-dimensional surface because we need 2 pieces of information to specify a position, the amount east and the amount north. And even if we use the overall vector of length 5, we need the angle information as well, and that's a second piece of information. If we represent the grid of the city with a mathematical grid with 2 axes at right angles, we have what's called a Cartesian coordinate system, named after René Descartes. When you drew graphs at school using the x and y axes, you were using Cartesian coordinates. The position of the hotel, 4 east, 3 north, could be shortened using Cartesian coordinates, 4, 3. And we can write this another way too if we invent unit vectors along the axes. A unit vector is a vector of length 1 in whatever unit system we're using. In our example, the units are blocks. We call the unit vector in the x direction I, and we use j for the y direction. Then our hotel position, relative to us, can be written in vector form as r equals 4i plus 3j. Here's the same thing redrawn, but sort of in 3D as though we were looking at the ground from an angle rather than from above. Now imagine that our hotel room is on the 5th floor of the hotel. And just to be mathematically picky, even if it's physically unlikely, let's say that a story of a building is the same height as a block is long. So the position of our hotel room is 4 blocks east, 3 blocks north, and 5 stories up. We're now locating in 3-dimensional space because we need 3 pieces of information to specify the location. We can extend the Cartesian coordinate system to the 3rd dimension by using a 3rd axis, which we call the z-axis. And then the position of the hotel room could be shortened using Cartesian coordinates 4, 3, 5. And we can also generalize the unit vectors by inventing a unit vector called k in the direction of the z-axis. Then the position vector r is r equals 4i plus 3j plus 5k. Any vector a in the 3-dimensional space can be expressed in Cartesian coordinates in terms of its x, y and z components as a equals the x component times the unit vector I plus the y component times the unit vector j plus the z component times the unit vector k. We can think of this as scaling up each unit vector, I, j, k, by an amount equal to its component in that direction. We can also write it in column vector form, like this. What if someone else wants to know the hotel room position, but they don't know where we are? That means on the diagram they don't know where the red and yellow circle is. Well, we can do the same thing, but our position is not a good starting place for them. We need a new starting point or origin for their position vector. Let's put it here because there's a landmark here which everybody knows about. Then we can give directions if we know where we are relative to the new origin. Our original position relative to the new origin is represented by the vector s. S equals 6, 2, 0, where the 0 in the z direction signifies that the origin is at ground level. Remember, our hotel room relative to us was at 4, 3, 5, represented by the position vector r. So the hotel room position relative to the origin of the coordinate system can be found by adding the 2 vectors r and s to form a new composite vector t. We can write this in different ways. This first way adds the i's, j's and k's of r and s to find the components of t. And this second way does the same, but in column vector notation. Why would we bother doing any of this? Well, we've already seen one answer to this, that you can treat the components separately, and that makes life a lot easier. We'll see this later when we look at a problem involving projectiles.